We've talked about solving equations before, and we've talked about that when we solved them before, we factored, right? So that it's equal to 0. Sometimes we'll come across ones where factoring will be difficult. So there might be other ways that we might want to try to solve the problem. And also, in some problems, we'll have equations that will involve complex numbers. And typically, we didn't see those complex number things pop up when we were doing factoring and solving equations. So today, we're going to talk about a couple of other methods for solving equations. You may have seen these before. One is called the square root method, and one is the quadratic formula. All right. So let's go through each of these, do some example problems. So when we're talking about the square root method, we notice that we have a perfect square on one of the sides. And what I mean by that is, notice in the two examples that you have here on the notes sheet, I've got a simple x squared there. That would be a perfect square on the left-hand side. Over here, I've got an x plus 5 squared. Again, be a perfect square on the left-hand side. So when you're doing the square root method, the idea is we want to get rid of that square by doing something to both sides. And given the name of the method, what do you think you want to do to both sides? Take the square root, right? To get rid of the squaring, okay? So we will take the square root of both sides here. Now, one thing that you have to be very, 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 very careful with when you're doing square roots of both sides of an equation is, remember, when we do the square root of something, we mean the principal square root, the positive square root, right? But remember, when you square a negative number, it becomes positive as well, doesn't it? Okay? So anytime that you use the square root property, you need to make sure that you do plus or minus when you take the square root. Okay? The reason for that is because if I work backward and go from this step to this step, if I work from here to here and squared both sides, it wouldn't matter if it was positive or negative. When you square it, the negative becomes positive, right? You get the same answer. Okay? So, rule of thumb, if you take square root of both sides of an equation, you always get plus or minus. Okay? Always. Which means we'll have two solutions here. Okay? So, when we simplify the left-hand side, we would just have an x. On the right-hand side, now we want to try to simplify this radical. Now I've got square root of negative 18. If I want to simplify this radical, we always handle the negative first. How do we handle the negative under the square root? I, right? And now we'll simplify square root of 18 like we always do. You can do it a couple of ways, but if we do our factor tree, what multiplies to give you 18? 6 and 3 works, and then 6 is 2 and 3, and I see that pair of 3s. So how can you rewrite square root of 18? 3 squared root of 2, good. So I'd have 3 times square root of 2 times I, and negative 3 times square root of 2 times I. So just to remind, when we write plus or minus, we mean the positive 3 root 2i works and the negative 3 root 2i works. It means there's two solutions. Pardon me. Gosh. So if you wanted, for example, if you wanted to write it out longhand, you could write it as x equals 3 square root of 2i and negative 3 square root of 2i. That means the same thing. I'm just trying to emphasize that it means the same thing. You're writing down two solutions in a compact form. Does that make sense? Yeah. Right.
Write it like that
I
in Hawks.
don't remember off the top of my head. If there's a plus minus key in Hawks, then no. You can. If there's not a plus minus key, then you'll have to write it as two separate ones. I don't remember if there's one in that keyboard thing or not. It's been a while since I've actually typed it in there. So, what's that? It's not in there? Okay, so you'll probably have to write it as two separate solutions then. Okay. All right. So now let's do the same thing for the next one. I have x plus 5, the whole thing squared. So your first step would be to do what to both sides? Square root, good. Oops. Because again, that square root undoes the squaring. So we get, and if you want to, you don't have to write this middle step that I have on here currently. If you can go from here to here directly, that's fine. Do not, however, forget your plus or minus. That's important. Is there anything I can do with square root of 13 to break it up? I don't think there is, right? 13 is prime, right? It's 1 times 13 and that's it. Not a lot I can do here. To solve for x now, subtract your 5. Typically, we write the part without the root in it first and then the part with the root in it. So write it as negative 5 plus or minus square root of 13. And again, to emphasize, this means that there are two solutions. One with a plus sign in the middle and one with a minus sign in the middle. That okay? All right. So square root method works very, very nicely if you've got a perfect square on one side so that you can take the square root of it. Now, of course, life's not perfect. So other problems probably don't have a perfect square. And also with the life not being perfect idea, not everything factors nicely. So that's where the quadratic formula comes in. You've probably seen quadratic formula before. So first, before you use your quadratic formula, you have to do the same thing that we do when we start to try to factor something. You have to have equal 0 on one side. You have to move everything to one side and put equal 0 on the other every single time. Okay? Now, we label the coefficients on the x squared, the x, and the constant as a, b, and c. So the a goes on the x squared, the b goes on the x, the c is the constant. Then you can plug in those numbers into our formula for the quadratic formula. All right, so let's just see how this works. We have the equation 3x squared plus 5x minus 7 equals 0. In this, just to label the parts, you don't have to label the parts every single time, but just to label the parts, your a is 3, your b is 5, your c is negative 7. Make sure you keep the signs in there, right? If it's a minus sign, then there's a minus goes with it, okay? So now we'll use our quadratic formula. It says do the opposite of b. So b is 5, so we have negative 5. Get plus or minus b squared. So 5 squared minus 4 times the a is 3 times the c is negative 7. And then it's all over 2 times 3. 2 times the a. Now, a couple of things to make sure that I want you to be aware of, to be careful with. This is important. Again, I already mentioned, make sure you keep your negatives straight, right? Because notice here, when you multiply this out, you'll get a negative number, so it'll change that to a plus. All right, so negatives are important here, okay? The second thing, this fraction bar all the way across, okay? So this number is divided by this, and the square root piece is divided by that. One of the common errors that I'll see students do is only put the 2a under the square root part. It goes, the whole thing is over 2a. So be careful with that. All right. Now it's time to just simplify as much as you can. Five squared is 25. Let's see, what do we get? Negative 84 when we multiply those things together. You get 12 times negative 7. Minus a minus makes a plus. 25 plus 84 gives you 109. And I believe 109 is prime, so I think you're done at that point. That's not much else you can do. Again, remember the plus or minus refers to the fact that you have two solutions, right? So if you were to write out the two solutions, you'd have negative 5 plus square root of 109 all over 6. Negative 5 minus square root of 109 all over 6. And the big deal that I was just making a minute ago about your fraction bar, I do know that some of the problems in Hawks will ask you for decimals. Make sure when you type this, especially if you're going to type it in your calculator all at once, make sure that you use your parentheses. Like that. Okay. Make sure you have the parentheses around it. Yeah. Okay. Is that what happens? Yeah. So remember when you type in the square root key in your calculator, a parenthesis pops. It depends on your calculator. Sometimes the square root bar goes over the whole thing, and that's okay. Otherwise, you have parentheses. Make sure you close off the parentheses here and on the top. Be careful with that. If you forget this one that closes off the top, it'll still just take the 6 and divide it into the square root and not the 5. Okay. I know I'm making a big deal out of it, but these are little errors that you see from time to again. Okay? Again, if you can simplify this piece, you should try, but sometimes you can't. All right. Let's see if we can just go through a couple of these examples here on the notes, and then I'll set you loose on your worksheet. In general, if you can factor, you should try to factor because it's faster. Okay? So let's look at the first problem. Can you factor the left-hand side? How does it factor? Good. Yeah, I can get, notice I have x squared, so I'd have x and x. 4 and 3 together will give me a 7, right? So that factors as x plus 4 times x plus 3. Again, if you can factor it, it's faster. Okay? Now, if you don't see how to factor it quickly, don't spend all day trying to factor it, because the quadratic formula will always work, whether it factors or not. Okay? There's just more chances to make a computational error when you're using a quadratic formula. But if you don't see how it factors, use quadratic formula. That's okay. All right. So now remember your zero factor property. We said each piece equal to 0. And then subtract your 4. Again, if you want to see how this would have worked with quadratic formula, give it a shot. Okay? Use A equals 1, B equals 7, C equals 12. We'll go through the quadratic formula, see that you'll get the same answers. You type it, plug everything in correctly, you should get both of those answers. All right. Let's look at number 2 here together. Notice that I see this perfect square piece given to me, so that's what make me think maybe square root method might work nicely. But I have to have this thing all by itself before I can do the square root. So what do you want to do to both sides first? Get this piece all by itself. What do we want to do to both sides first? I want to get that squared all by itself, so what do we want to do to both sides? I want to see that x plus 5 squared all by itself. Do I want to add it? Because it's multiplied. That's what we wanted to do. If you had just this, what would you do? And move the negative. How do I move that -2 to the other side? Divide it, right? What do you think I want to do in this case? Divide it. Yeah, I just want to get that x plus 5 squared all by itself. So the first thing we'll do is divide both sides by -2. So we get x plus 5 squared equals -12. I want to isolate that squared piece. The reason I want to isolate the squared piece is because now I want to take the square root. I want them to go away, right? So if we take the square root of both sides, your left-hand side becomes x plus 5. What does the right-hand side become? Good. Very good. We want to make sure that we don't forget the plus or minus. So you get plus or minus the square root of -12. And now I'm going to simplify this first before we move the 5 over. Make it look a little bit nicer. What do we do with the negative under the root? Make it an I. And then can we break up 12? Four and 3. And 4 is 2 and 2, right? So we see the pair of 2s. So how can we rewrite square root of 12? With 2i times square root of 3. And then we will subtract the 5 over. Again, this means that we have two answers, right? We have -5 plus 2i root 3 and -5 minus 2i root 3. There's two answers here. I know standard form says put the I behind, right? If you type it in Hawks, you probably have to put it behind. I just think it looks better this way because I don't have to look at where the I, if the I is under the radical or not. Writing it down for me, I don't care which way you write it. That one okay? Okay. Let's look at this last one, where we've got 2x squared plus 5x plus 6 equals 0. Again, if you can factor it, it's faster to factor. But again, don't spend all sorts of time trying to factor it. Okay? I don't think this one factors. Okay? So if it doesn't factor, we'll use quadratic formula. What's your A? Yeah, the 2 is the A, the B is 5, and the C is 6, right? So x equals, what comes first? Yeah, the -5, good. Plus or minus square root of 5 squared minus 4. Yep. Oops, that was weird. 4 times 2 times 6, and then all over 2 times 2. Good. Five squared is 25. 4 times 2 is 8. Times 6 gives me minus 48 all over 4. (25) minus 48 gives you negative 23. So again, now at this point, we should try to simplify the radical if we can. In this case, there's only one real thing that we can do to simplify the radical. To take care of the negative under the radical, how do we write that? What do we do with the negative? Make it I. Okay. Now, as far as I'm concerned, this is a perfectly good way to leave this problem. Okay. Now, on Hawks, again, Hawks likes you to write things in standard form, right? Okay. If you're going to write this in standard form, I'm going to write it down and then we'll talk about it here. So I told you before, again, everything above the bar is above the bar, right? So I've got negative 5 divided by the 4. And then you've got a plus and you've got a minus. So that's where the two different ones come from. You'd have the square root of 23 over 4, and then the I would get tagged on the end. So it looks exactly the same, except with one's a plus and one's a minus. That's how you would do it in the standard form and split it into two. Yes?
So when do we use the quadratic formula? Because you didn't use it in 1, but used it in 3.
I could have used it in 1, but factoring is always faster if you see how to factor it. That's why I didn't use it in the first one, because we can see how to factor it pretty straightforwardly.
All right.
But if you would have used the quadratic formula, you would have got the same answers when you simplified. It's okay? So work on the worksheet. Holler at me if you've got questions.